All right, so today we're going to be looking at 11.2, dealing with congruences with our triangles. As we saw in the previous lesson, our congruent triangles are going to have 6 pairs of congruent corresponding parts. So the 6 pairs come from 3 with the angles and 3 with the sides. And they tell you that the converse of this statement is also true. So if you know that your triangles have 3 pairs of sides that are corresponding and congruent, and you also have 3 pairs of angles that are corresponding and congruent, that means that your triangles are going to have to be congruent because all of the corresponding parts are congruent. So looking at Greg, again, with these triangles in his trusses, he wants to know if they're congruent, and he's trying to find a shortcut, like you always want to do. You students always are looking for shortcuts. He's wanting to know, do I have to measure all 6 parts of both of the triangles? Or is there something that'll allow me to measure fewer parts and then stop after I've measured those parts to find out that they are congruent? So that's what we're going to be looking at today, trying to find a shortcut. So he's going to start by checking just one pair of the corresponding parts of his 2 triangles. So you're supposed to be doing this in groups. I'm just going to walk you through it. All of this is supposed to be group work, and then we're discussing as a class, but I'm just going to walk you through it as what you should end up. So you may want to pause the video throughout to attempt it yourself, and then check and see if you agree with what I did. So we're going to start by checking just one pair of corresponding parts of 2 triangles. So you're going to draw one triangle that has a side that is 2 inches long, and then draw another triangle that also has a side that's 2 inches long. And it says that the other 2 sides can be any measure. And it wants you to do it on patty paper. And so we are going to see, are our triangles congruent to each other? So I'm going to draw 2 different triangles. So I'm going to do it on 2 pieces of patty paper here. And I'm wanting to see, are my triangles going to be congruent? So it said 2 inches long for one side. So I'm going to use a ruler. So that's 2 inches. And then it said any side length for the other 2. So I'm going to make one that appears to be a right triangle. And it doesn't matter how long that one is. But I'm not going to put a right angle marking there, but I'm going to say it looks like a right triangle. And so there is my one triangle. And then it says make 2 triangles. So again, make a side that is 2 inches long. So this is 2 inches. And this time I'm going to make not a right triangle. I'm just going to make some random triangle. And so, are these triangles congruent? So part A was to draw your 2 triangles. Part B, are your triangles congruent? Well, you can see that this one side that measured 2 inches is congruent, but my 2 triangles are not congruent. So for part B, will all of them be congruent? No. Could they be congruent? Yes. You absolutely could draw the exact same triangle, but what we're looking for is pairs of triangles that are not going to work for what they are asking you to do. So our triangles aren't congruent. No way am I going to be able to turn, reflect, rotate one triangle so that it maps to the other. So then, looking at part C, it asks you to cite your results from what we just did to prove or disprove the statement. If one part of a triangle is congruent to a corresponding part of another triangle, then the triangles must be congruent. And that's not going to be true based on what we just looked at. So it tells you to cite what you just did. We just drew triangles that had one side that were the same length. They were both 2 inches. So one of my triangles had side length of 2 inches, and the other triangle had a side length of 2 inches. But those triangles were not congruent to each other. So having one part that is congruent does not make your triangles congruent. Okay, so let's look at the next part. Number 2, he wonders if checking 2 pairs of corresponding parts is going to be enough to show that your triangles are congruent. So another way to word this, if 2 parts of your triangle are congruent to the corresponding parts of another triangle, does that make the triangles have to be congruent? So there are some options for 2 parts. You could have 2 sides. You could have 2 angles. Or you could have 1 side, 1 angle. So on the 1 side and 1 angle, there are specific types where you could have your side and angle adjacent. Or you could have your side and angle not adjacent or opposite. And we're going to look at each of these 4 in A through D. So part A is talking about one side congruent to AB and another side congruent to AC. So this one is going to be part A. So I'm going to use my patty paper. And if you measure it, it's not exactly a certain number of inches, and it's not exactly a certain number of centimeters, but it was definitely closer on the centimeters. So I ended up going with centimeters on this one, just so that I wasn't trying to keep up with exactly how many inches or centimeters it was. So if you measure it, it's almost 5 centimeters for side AB. And then for side AC, it is about 3.5. It's almost exactly 3.5. So I'm going to make a triangle. It says AB is 5 centimeters, and then AC is 3.5 centimeters. So I'm going to make one triangle that has a 5 centimeter side. And remember, the goal is that you're trying to make a triangle that's not the same. I obviously could just trace over that figure and they would be identical. But I want to see if given those restrictions, do they have to be congruent? And so then this is going to be side AC that's 3.5 centimeters. And so to connect these two, we'll create my third side. And so if you look, this triangle is not congruent to the one that they gave me. No reflection, rotation, translation, none of that will make them congruent. So it says use transformations to check, and it's not. Not all of them are going to be congruent to the given triangle. The angle in between your 3.5 and your 5 centimeters doesn't have to be this specific angle. And that's what's going to determine if your triangles are congruent or not. So if you look, this side is the 5 centimeters, AB, And AC is 3.5 centimeters, but the angle A, there wasn't a specific angle marked for it, so it could be anything. And that's going to determine if your triangle is congruent or not to the one that they gave you. So A is not necessarily going to produce congruent triangles. So then it looks at part B. It says an angle congruent to angle A, because that's what we were just looking at. Angle A was critical to determining if they were congruent. And then it says an adjacent side. So this is where the side and the angle are adjacent, which is part B. So that's another one that we're going to try. Is that going to be enough to determine that we have congruent triangles? So I'm going to again draw side AB, which we've said is 5 centimeters. So that's the 5 centimeters. And then for angle A, we need to measure it with our protractor. So remember, you want to line up your little hole with the vertex. And then when I go to measure it, I get about 30 degrees. Okay, so I need to make a 30-degree angle here. So what you can do is put your protractor such that you've lined up right there, and then go mark at 30 degrees, and then connect that vertex with your little mark. And that creates a 30-degree angle. And so it may not be 100% accurate, because angle A you may feel like is 27, 28, 31 degrees. But you'll get a really good sense for, does it have to be congruent to the one they gave us? So C can go anywhere on this side. If this is A and this is side point B, C can go anywhere along this side. So I could put it here. Well, I didn't exactly hit through B perfectly. Or I could put it here. Either one of them would work. Anywhere along this side is where C could go. And so if you look, I've got the angle and I've got the 5 centimeter side, but it's not necessarily going to be congruent unless your C is right there. And it could be there, but it doesn't have to be. It could be anywhere along here. And so is every triangle that has an angle and a side going to be congruent? No. This side length of BC could be a lot of different lengths. Same thing with A and C. It could be a lot of different lengths. So that doesn't necessarily create congruent triangles. So looking now at C, it says an angle congruent to angle A, and then a side opposite to CB. So that's going to be the side and the angle that's opposite. So we're going to try this one. So we're dealing with CB. So we need to measure CB. And so if I measure it, I get that it's approximately 2.5 centimeters. So I'm going to measure angle A. So I need a straight line here. It doesn't really matter. It didn't specify how long that one needed to be. But this is going to be where A is, and it needs to be 30 degrees. So I'm going to create a 30-degree angle like I did last time. And it's going to end up going into that other figure, which is okay. And then it says that the side length of CB is supposed to be the same. So we said CB is 2.5 centimeters. So here's our 30-degree angle. And then I'm going to put my 2.5 there. That's 2.5 centimeters. Is that necessarily congruent to the triangle they gave us? That side length is the same length, and that angle is the same measure, but that's not going to produce congruent triangles. And that's because this side could go anywhere. It could go here or here. It just needs to connect from here to here and be 2.5 centimeters. So some of these may not be exactly 2.5 that I was just drawing, but here's one. It could be right there. And there would be your triangle. But that's still not exactly congruent to the triangle that they gave you. So I would have to draw it specifically from here to here for it to be congruent to the original triangle. So an angle and a side opposite do not produce congruent triangles. So your other angles and sides could end up varying to produce a different sized triangle. So B and C show you that one angle and one side is not enough to know if you have congruent triangles. Then the last one, dealing with D, you're supposed to draw triangles that have an angle congruent to angle A and an angle congruent to angle B. So that's our last possible option, 2 angles. So this is D, because both of these were covered between B and C. So we're going to look, do 2 angles mean that you have congruent triangles? So we know angle A was 30 degrees. That's what we measured earlier. And then we know angle B, if we use our protractor, is 40 degrees. So I'm just going to draw a line. And then if I start on this corner and make a 40-degree angle, 40 and 140 are the same. So I can make my angle here. And that's my 40-degree angle. And then I want to start here for my 30-degree angle. And so there's my 30-degree angle. And as you can tell, those are not congruent. They're the same shape, but they're different sizes. Whenever you have angles, 2 angles that are congruent, it's not going to produce congruent triangles. It's actually going to produce triangles that are similar. It's basically a dilation. So they're the same shape, but they just may be smaller or bigger. So dealing with 2 angles is not enough to tell you that you have congruent triangles. So, like I said at the beginning, you might have lots of different triangles from what I have. Those are just some examples. You're just wanting to make sure that you're looking at the correct parts on these. So then, looking at E, it asks you to consider this statement. If 2 parts of one triangle are congruent to the corresponding parts in a second triangle, then the triangles must be congruent. And it wants you to prove or disprove it. And it's a disprove. The triangles that we just did in A through D are all counterexamples to disprove this statement. We went through all of the possible options for having 2 pairs of corresponding parts being congruent, and none of them produced congruent triangles. So now let's look at the next one, number 3. He decides that he needs at least 3 pairs of congruent parts to know that he has congruent triangles. And so he decides to make a list of all the possible combinations for his 3 parts. And so now we get into our congruences that we're going to be learning. You're going to need to know A represents angle. First letter of angles, A. S is going to represent your sides. So if they write SAS, that represents side, angle, side. And the order on these is going to make a difference. And so we're going to be looking at some different options. He makes a list of 6, and we are going to mark the sides and angles in his list. So they already said side, angle, side is what they show in the first triangle. You have a side, an angle, and a side mark. So this is an example of side, angle, side. When you are making the marks here, you need to make sure that you're not skipping a side and an angle. So on this one, we didn't skip anything. We went straight from the side to the angle and then to the side. On the next one, side, side, angle. So pick a side. So side, and you can go counterclockwise or clockwise. It doesn't matter. You just got to make sure you go in a circle. So if I go side, the next one is a side. So I can skip an angle to go to another side. And then I do the very next angle. So that would be an example of a side-side angle. The next one they give us is angle, side, angle. So angle gets marked, the side gets marked, and then I go to the angle. The next one that they give us is angle, angle, side. So I'll mark an angle, I'll mark another angle, and then I mark the very next side. So as you can see, both of these have 2 angles and 1 side. The difference is that the S is in between the 2 A's on the left one, and it's not in between the 2 A's on the right one. So that is something that I'm going to discuss in just a moment more specifically. I want to go over the last 2 first. Side, side, side means that you have all 3 pairs of sides marked. And you do have to have different numbers of tick marks on each of those. Same thing with angle, angle, angle. All 3 angles are marked, and you're going to need different numbers of arc marks on your angles. You can have different representations on these. You just need to make sure that you've got the right order. So I told you, looking at angle, side, angle, and angle, angle, side, there is a difference. And the difference is it included or not included? So included versus not included. So I'm going to make up a little triangle here. If you're looking at our triangle, angle L is included. It is in between 2 sides. It is the included angle of side LK and side LM. However, L is non-included between side LK and KM. Because if you look, it is not in between those 2 sides. It's also not included between LM and KM. Okay, so that's what an included angle is versus a non-included angle. Looking at an included side versus a non-included side, looking at side LM, it is included between 2 angles. So if you look at side LM, the 2 angles on either side of it are angle L and angle M. And so then LM is non-included between angle L and angle K. And it's also not included between angle M and angle K. So you have to pay attention to included versus not included when you're looking at these. So then they ask you, are there any other possible combinations that he did not mention? And there are. Side, angle, angle, and angle, side, side. And yes, that means that there is an inappropriate word on the board. You're not going to say the word. It's not appropriate to say at school. Either say A, S, S, or simply say angle, side, side. But don't just say the word, okay? However, side, angle, angle was covered with angle, angle, side. Same thing with angle, side, side. It was covered with side, side, angle. So we don't need to add them to the list because they were already covered. So let's look at the next page. They are wanting to find out which pairs of congruent corresponding parts are going to force you to have congruent triangles. And so we are going to be using patty paper. If you wanted to use straws to do parts of them, you could. But they want you to take and recreate the 6 figures here. Figure 1, 2, 3, 4, 5, and 6. 1, 2, and 3 are angles. 4, 5, and 6 are side lengths. And they want you to identify which of those is which part. So if you use your patty paper, you can trace over these. This is figure 1. This is figure 2. This is figure 3. And then you have your side lengths. And if you do it on your patty paper, then you're able to easily tell that figure 4 must be side AB. So that's what you would put here, figure 4. And then you can tell that AC is figure 5, which leaves side CB to be figure 6. And then angle 1, or figure 1 is angle A. Figure 2 is angle C. And then angle B must end up being figure 3. Okay? So that's what we're dealing with. And then they want us to use this chart. And this is the part of the lesson that you might try and get hung up with. And so I'm going to go kind of quickly because it's a lot. If I spent an adequate amount of time on each one, this video would be extremely long. So I'm going to try and talk while I'm working. So they want you to list out your combinations. So side, 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 angle, side, angle, side, angle, 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 side, angle, 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 and side, side, side. I'm sorry, side, side, angle. So those are the possible ones. So when you're looking at side, 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 there are only 3 sides, and the order doesn't really matter. But we are looking for, they say to use the numbers. I am wanting to use the side lengths just for clarity a little bit. So those are our 3 sides. And if you go to make a triangle using these 3 sides, you're going to end up with the exact same triangle that they gave you. And I'm going to do it on the SmartBoard because this is one where it helps if you have like straws or sticks or something, and we don't have that here for all of y'all to use. So what I'm going to do is just trace each of the side links. In a different color. And then if I take them, here we go. Well, and I try and move them around, there's only going to end up being one triangle that they're going to create. And it's going to be, that one's just a reflection of the one that they gave you. If you look using maybe a pen, a pencil, and another pen, whenever you start trying to move them around, all you're going to end up doing is having reflections or rotations of the same triangle. So if I gave you 3 links, you're only going to ever be able to make one triangle with it. So will this produce congruent triangles? Yes. So they are trying to make you to create a triangle that's not congruent. So when you're looking through these, you're trying to make one that's not going to be the same. So now let's do side angle side. There are 3 different options. And if you look in the notes, I list out all of them, but I'm just going to do one of them in here. But if you look on the notes pages, you'll see all of the 3 options listed. So angle AC, side AC is figure 5. So I'm going to take my patty paper and flip it over so that I can put side AC onto my white paper. So there's my side AC. And then the very next thing, I need to put angle A, which is figure 1. I can either put it here or I could put it over here. So I'm just going to put it here. And then it's important that you know this angle can extend. It doesn't have to stop right there. It just needs to have that same angle. So it could go anywhere down there. And then side AB. AB was figure 4. So it's going to end up needing to go, as you can see, a lot further out. And that is going to produce a triangle that ends up being congruent to the one that they gave you. As you can see here. Well, you may not be able to see that it ends up matching up there. So this one, side angle side, yes, is going to work. So these 2, same idea. They will work. You're going to have to practice using your little patty paper or your straws or something like that for them, but they do end up working. All of the different options, there are 3 here. There are 6 different options on this one, but they all end up working. For this one, angle A, angle B, angle C, those are your only options. If I make a triangle with these angles, do they have to be congruent? And that's no. No, it's not going to work. So let's say I have this one right here. And then I have this angle here. And then I have this angle here. Wait, not that one. This one. That produces where this was angle 2, this was angle 1, this was angle 3. But as you can tell, my triangles are not congruent. They are similar because they have the same angle measurements, but they are definitely not the same size. So angle, angle, angle does not necessarily produce congruent triangles. And then the last one to look at is SSA. So there are 6 different options on this one. I'm just going to list one of them. So angle C, and then side AB and side BC. So AB is number 4. I'm going to start with number 4. BC is 6. So I can put it here maybe. And then angle C was figure 2. And it ends up over here. And that doesn't even make a triangle. Like if I extend it, this side length is set. So if I extend it, like it's not going to make a triangle that's going to be congruent there. So this one is also a no. So it asks you to list out the ones that did work. So there were 4 of them that did work. Side, 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 angle, side, angle, side, angle, and angle, angle, side. And these are called your triangle congruence criteria. So it tells you over here, criterion is the plural, is a singular. Criteria is the plural. That's a Latin root, is why it goes from an ION to an IA for the ending. Some books call them triangle congruence theorems. So I may sometimes refer to them as your theorems, your triangle congruence theorems. They call them in this book the criteria. So these are the 4 that work. If you notice, side, side, angle, and the reverse of that, angle, side, side, did not work, as well as angle, angle, angle. And so they ask, why do you think that one does not work? And it's because angle, angle, angle might result in triangles that are not the same size. We have shown that it's possible for 2 triangles to have 3 pairs of congruent corresponding angles and yet still not be congruent, because they could be similar. The sizes of them could be different, even though they're the same shape. So these are the 4 that you want to practice. Make sure you understand that you know. Those are the 4. Side, side, side. Side, angle, and angle, angle, side. So let's look at the next page. They give us a couple of examples, and we want to write how we know that the triangles are congruent. Well, if you look at A, they have side, 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 side. So these triangles are congruent by SSS. For part B, they have an angle mark and they have a side mark. There are other things that you can mark sometimes. And that's what they tell you in this box over here on the left. You can use your theorems about vertical angles. So what are vertical angles again? That's where this angle here is congruent to this angle. They are not adjacent, they're opposite whenever you have lines that are intersecting. Likewise, this angle and this angle are congruent. Those are vertical angles. You could also use some theorems or definitions about midpoints or a bisector. A midpoint and a bisector of a line segment, cut it in half. So if you have a line segment and you know that you have something bisected, this part and this part are congruent. That is the midpoint of the segment. For an angle bisector, you have an angle bisector. If that line segment is bisecting the angle, these 2 angles have to be congruent. And then you could also be dealing with your parallel lines that are cut by transversal, your angle pairs that we talked about back in activity 7. if I have parallel lines and a transversal, this angle and this angle are congruent because they're alternate interior angles. Likewise, this angle and this angle are congruent because they're alternate interior angles. So you want to look for that information after you see what they have already marked. These angles are vertical angles. And so if you look at this one, I'm going to list out the 4 that we know. They mark 2 angles and a side. So it can't possibly be side, side, side. Nor could it be side, angle, side. And you may say, wait, side, angle, side. But you only look at one triangle at a time. So if you look at this triangle here, you have one angle, one side, and another angle. So we know it's not side, angle, side. So is it angle, side, angle, or angle, angle, side? This is where the included versus non-included comes into play. Is the side in between or not in between the angles? And on this one, it is in between the 2 angles. So it is by angle, side, angle, which is what they tell you there. So try A and B, and then let's see if you get it right. So on A, this is the first time they talk about this, but these 2 triangles share this side right here. So that means that they have to be congruent. Anytime they share a side, they're going to be congruent. So on one triangle, I have a side marked and I have another side marked. But there are only 2 things marked, and I have to have at least 3. So this would be none. They are not congruent. Looking at B, these little arrows mean that this line is parallel to this line. And then this is your transversal. So that's creating this angle and this angle that are congruent. It is not saying this angle and this angle are congruent because that is not your alternate interior angles between your pair of parallel lines. So you got to make sure that you look closely at what your parallel lines are. So this angle and this angle are congruent. This side and this side are congruent because they marked it as such. And then this side they share. And so are these congruent? We'll look at one triangle. They mark a side, and an angle. And so if you look at your list, the only one that even has 2 sides and an angle is side, angle, side. And you need to check, is the angle in between the 2 sides? It is, so it's congruent by side, angle, side. So now let's go to the next part. Number 8 asks, 2 triangles each have 2 sides that are 8 feet long, and the included angle is 50 degrees. Must they be congruent? So I drew a figure here. And the triangles, it's not so much that they're to scale, you're just trying to get an idea, are they congruent or not based on information. So they may not look congruent, but plug in your information and then look. It says 2 sides are 8 feet, so we know these are both 8 feet. And then the other triangle also has 2 sides that are 8 feet. And it says the included angle is 50 degrees on both of them. So are they congruent? Yes. And how do you know? The 2 corresponding sides and the corresponding included angle are congruent. And so they are congruent by side, angle, side. For number 9, you have 2 equilateral triangles that each have a side that's 5 centimeters long. So equilateral means that all 3 sides are the same. So if one of the sides is 5 centimeters, that means the other one is 5 centimeters. And then it says I have another equilateral triangle. So again, all of the sides are congruent, and it says that both of those triangles have a 5 centimeter side. So are those 2 triangles congruent? Yes. An equilateral triangle has three sides with the same measures. If one side of an equilateral triangle measures 5, all of them measure 5. So all of these measure 5. Same thing over here. Since the two triangles both have all three sides that measure 5, the triangles have to be congruent by side, side, side. Looking at number 10, the figure shows a circle and two triangles. It wants to know what we would need to be able to prove that the triangles are congruent. So we're going to first look at this length here from C to the edge is a radius. This length is also a radius, so they're congruent. This length and this length, they are all a radius of the circle. So that means that all four of those segments are congruent. So we can either potentially use side, 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 or side, angle, side. Those are the two options that have two sides. If they told us that this angle was congruent to that angle, we would be using side, angle, side. If they told us that this side length and this side length were congruent, then we would be able to use side, side, side. So we need to know one of those pieces of information to be able to tell if the triangles were congruent. So now looking at the practice for lesson 11.2. We want to know, are they congruent or not? So if you look, if I want to start here and go this direction, I would be skipping this angle and this side. And I can't skip both an angle and a side. So I know that I can't go that direction. But I can go this way, maybe. So I'd have side, and then I get to an angle. It's allowed to skip this side here because I get that angle right there. And if you look, side, angle, angle is not one of them, but angle, angle, side is. So you wouldn't use side, angle, angle. You would use angle, angle, side. Looking at number 12. They've marked two pairs of sides congruent. We can add the third one. And so that means they are congruent by side, side, side. For 13, we can add these vertical angles here, which makes them congruent by angle, side, angle. And again, if you're not sure where to start, if you want to start here at the side and then go to angle, if you try and keep going, you skip a side and you skip an angle, and you can't do that. For number 14, it's not telling you that the sides are congruent, it's telling you they're parallel. So this side is parallel to that one, and there is your transversal. So we know this angle and this angle are congruent. Likewise, this side and this side are parallel, and there's the transversal. So this angle and this angle are congruent. So I'm going to mark that without the lines drawn. Those are congruent, and these are congruent. And then we also share this side in the middle. And so these are congruent by angle, side, angle. Looking at the last one, the one additional piece that we would need, if any, to conclude that they are congruent, they tell us we have a right angle here, which means we have a right angle here. And then they share side BD, so we know that BD has to be congruent because they share it. So that's two pieces of information. We need at least three. So when we're looking at side, 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 angle, side, angle, side, angle, and angle, angle, side, we are not going to be using side, side, side because we already have one side and one angle. So if we wanted a second angle, we could do that. And we would a second side, we would need to know that these sides were congruent. So we would have to know that AD was congruent to CD. So that'd be one way. Another option would be angle, side, angle. So angle here, side here, we would have to know that these angles up top are congruent. So we would need to know that angle ABD is congruent to angle CBD. Or if we're wanting to know angle side, we would need to know this angle here and here are congruent. So we would need to know that angle A is congruent to angle C. And so it wasn't asking you to list out all three of those, but those were the three possible options. So hopefully that helps you a little bit with lesson 11-2.